Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to take a look at wind power. So what is it? Well, it's a very simple concept. The idea is very simple. Wind is basically solar power. I already made a video about solar power there. Basically, sun creates a temperature differential, and based on that, wind moves. And also, it also helped by the fact that Earth is spinning. So it is solar energy. Directly, it is solar energy. It's just converted into different form. So you let that energy does the work for you. So it is a very old tech, as you can see, shale ships and all that, and Denmark and all that. It's kind of old technology. We know what it is, we inherently understand what it is. So how do we get electricity out of it? It's very simple. We put turbine, basically blades, and that they rotate generator, sometimes directly, sometimes like in small scale they generally directly rotate the generator. In something big scale, like few megawatt scale, they generally rotate a gearbox. Based on that, they rotate the alternator. And if you have a lot of wind turbines, we call them a wind farm. So this is how we get the electricity out of it. Now we have to specifically, as I already mentioned in my video about solar power, is that solar power is almost reaching cost parity. So what is its condition? Well, it has very low land footprint. Basically, let's say you are a farmer and you have very hundreds of hectares of land, and you can lease the land to some company that is putting up wind farms. Everything is good, you can use the land. That's the crucial part. It has very low land footprint, as you can see. Like in this context is very easy to understand. It's like this land is completely usable for agriculture and all other things. So very low footprint, as in like double profit. Okay, awesome. But it has very high initial capital cost. These structures that you see, they are not cheap by any stretch of the imagination. Inherently they are idiotically expensive, as in like they do provide a lot of power, they do provide a lot of benefits, but inherently, do you have the money to buy them? Short answer, no. Most people can't. And I mean countries also can't, because they are very, very expensive. And specifically the new turbines that are very big, they are more efficient, but they cost like 20-30 million dollar per piece, and you need hundreds of these. So suffice to say, capital cost is very high. Now that in itself would be a very big deal, but is also maintenance intensive. What does that mean? Basically, it has so many moving parts and it's directly working based on motion. Sooner or later something breaks, like the blade might get damaged. Let's say things happen, gearbox might break down, the generator break down. It has so many moving parts. The more moving parts you have, the more likely you have the opportunity that something's gonna fail. So in that sort of scenario, it's also maintenance expensive. Like maintenance is not free. Like, yes, there is a probability that your solar panel can break, there is a probability that solar inverter can break, but those probability compared to this versus that, it's not in the same path. So even though it has very low land capacity and the raw amount of energy it gives is very high, the capital cost is very damn high. Then if cost is so bad, then why there is so much interest about it? Well, it has the option to provide power 24/7. Basically, this is a wind farm and this provides power 24/7. Now this wind technology, as we have it, is the closest renewable energy that we have that reaches what we call base load power. As in my video of grid scale power storage, I specified the grid generally gives you a constant power output, and you want constant power output, so you can be like properly control it. Load will of course go up and down, but you always need to know that can I count on this farm to provide me this much power 24/7 into 365 until it's decommissioned. Yes. Now there is a lot of fluctuation, but due to our recent advancement in satellite technology and weather forecast, we can like see things coming a miles away nowadays. And all these things are placed in a very wind rich area where like we do a lot of R&D into making these. This is not like we just went there and put it. We did a lot of research, and more often than not, all the solar farms have this issue where no matter what you do at the night, they are like off, flat out off. this can provide power at night also, and day also, and in windy scenario, and in a rainy scenario. So all things considered, if you combine every data point, this can provide base load power. Now of course they have to scale down the base load. They cannot be like, let's say this power plant that I'm showing you here, India's one of the largest plant we have is like roughly 1000 megawatt. So their base load would be roughly, let's say 600. Just to be on the safe side, they can be like, okay, 600 is our base load. Okay, but they have base load. It will be producing that much power at night. And yes, there is a lot of ups and down, but ups and down is not on and off. It does not go to off unless they put it somewhere where there is a risk of it. Most places don't have it. So this is why there is so much interest in it. Like solar can flat out, it's almost reaching cost parity, and it does have the raw capital needed, like as in land mass and solar flux. It has everything needed to it that can allow us to power entire humanity based on solar. But problem is we do not have a gigawatt scale power storage, other than, as I made in my video, pumped hydro is the only one that can allow gigawatt scale power storage, but that can only go up as 2 gigawatts, and like these plants can produce that much power in 1 or 2 hours. So suffice to say, we really need very new level of technology for grid scale power storage. Flywheels is just not gonna cut it. Supercapacitor is not gonna cut it. So we need something on a whole different level for solar to be viable. Wind farm, on the other hand, is far more manageable. So what we can expect in the future? Well, the solar farm has this one advantage: the more you put on, like the more land mass you invest into it, the more profitable it becomes. So that's why you see the investment in ludicrously large wind farms, as this one is China's wind farm. As of now, as I speak to you, that's roughly 8 gigawatt, as in 8,000 megawatt, and they were planning to scale it up to 20,000 megawatt, basically 20 gigawatts. And we're gonna see super large turbine. As I told you, like the bigger the turbine, the more powerful it becomes in terms of like efficiency. As in, like, this is the turbine that I could find. That's the biggest turbine. That's roughly 9 megawatt of power from one turbine. So, but again, cost is idiotically high. But as more mass production happens, as more computer modeling happens, and simulations are done to make sure the cost is optimized, we can expect these to become cheap. And then we're gonna see a lot of offshore wind power. The reason for this, even though these have very low footprint, nobody likes to see this. This looks ugly, and they are very noisy. Now many people do not care, many people care about it. So to, you know, put it out of sight, out of mind kind of scenario, we want to put it offshore. And it has another benefit, the benefit being that because the water surface is smooth, the wind flowing on top of it is generally at few percent higher intensity, and we can predict weather on sea much more effectively than we can predict on land. Like on land, everything plays a role into it. Like, is there trees there? Is there a forest there? Is there a land mass there, like a mountain or a hill? But here it's a flat, so we can calculate it very efficiently. Only consequence of this is the idiotically expensive. The turbine itself is expensive. Then to make up pylons that either go to the seafloor or a floating pylon, suffice to say, it's kind of expensive. So I think in the future, as we move forward, and we have to make our grid renewable. Now you might be like, why? Like, why can't we just burn coal? Because coal is gonna run out. Let's say you don't care about planet, but you have to care where your electricity comes from. Like, flat out mining coal, over time the coal price has went up. Over time petrol prices went up. So sooner or later it will reach a point where it's just too damn expensive, or a point where you have no more coal. As in, like, it's just never gonna happen on an earth level, but cost will become so high that it will be like, yeah, you know, we can't use coal power plants to produce electricity cheaply. These will provide cheaply, so people will use this. It's all about economics. That's why China is investing so much. Like, they have flat out no consideration for atmosphere, and flat out they were the most polluting country, practically speaking, in terms of coal power plant. They did not even have flue gas treatments in many of the coal power plants. That's why they created what's the smog, basically, scenario, where the entire cities were covered into smog because the coal power plant nearby was not doing the basically necessary treatment. But even they are like, yeah, sooner or later we're gonna run out of coal, and like, what you gonna do then? And this sooner or later is not necessarily like, okay, today we have coal, tomorrow we don't have any coal. It's like, today our coal is, let's say, $100 per ton. Tomorrow it's $150 per ton. 2 years from now it's 300. and then it's like 700. At that point, it's like the electricity that you get out of it is so expensive that nobody's gonna buy it. Like, nobody's gonna pay their electricity bill if it's like, yeah, $50,000 in your electricity bill. People are like, yeah, no, no, man, no thanks. So for that reason, sooner or later we have to use renewables, simply because of our pocket. You don't care about anything else, but you have to care about your pocket. So wind plus solar equals almost all our problems solved, and plus with advancement in grid storage, grid scale battery storage, we can see a future where whole nations, I don't mean small nation in like, you know, European Union, I mean big nation, as in like USA, China, India, like big population, billion people kind of population, can be powered by renewables. And wind can play a very significant role in the coming future. So this was my presentation. I hope you liked it or learned from it. In that case, please like. If you didn't, don't worry about it, dislike it, and leave a comment what you want to see in the next episode of Science Thursday. And I would suggest you subscribe, press the bell icon, as I make video every day. And as always, thanks for watching.